We are moving on to section 5.4, which is all about E, the number E, how we work with it, how we derive it, how we integrate it. It is actually my favorite section of the chapter because I believe it's one of the most straightforward derivatives we have. And it also really picks up where we left off with so many other things in calculus. So we're going to spend, I'm going to do multiple videos on today's lesson, looking at the basics of E, how we derive E, and some examples with that. And then the next day's videos, we'll look at integration. So first, just a quick recap of what you should know about E from like an algebra 2 standpoint. So E is called Euler's number. It is an irrational number. It's approximately 2.71828. We basically treat it like pi. It's a number, but it's a number that gets a letter to represent it because it does go on forever. What we know about E is that E and natural log are inverses, so they undo each other. So if you look at the properties off to the side, if you take the natural log of E to a power, you just get that power. If you take E to the power of natural log, you just get whatever you're taking the log of. So you get a lot of canceling happening when you work with E's and natural log. For that reason, we use each other's operations to solve equations. So for example, looking at like the first two on the screen, if you wanted to solve something for x that has a natural log, you would I always call it exponentiate it. You would take both sides to base E. And what that does is it cancels the natural log. So you're left with 2x plus 5 equals e to the fifth. If you want to use a calculator, you can do that to get a decimal. I usually keep it exact. So I'm going to subtract 3, divide by 2. So my exact answer would be e to the fifth minus 3 all over 2. My calculator answer would come in from typing in e to the fifth minus 3 and then dividing that answer by 2. Same thing for the second one. To solve this, I would take both sides and make both sides have base e. That eliminates my natural log. On this side, we get e to the fourth as a decimal, or leaving it like that. My final answer would be e to the fourth plus 7, or a calculator answer would be a decimal. If it has e's in it, so going in reverse, if you're trying to solve an exponential equation that has base e, you're going to take the natural log of both sides because that will eliminate the e. Same thing. If you want to go to a calculator and get a decimal, you can. It really just depends on whether you're asked for an exact answer or an approximate answer. And you get the natural log of 7 minus 1. You cannot subtract that 7 and that 1 because the 7 is attached to the natural log. So if you want, you could write it as negative 1 plus the natural log of 7, or you could go to your calculator, just make sure you keep parentheses around that 7. And then the last one, we need to isolate the exponential piece. So we add 1. That will get rid of that. Then we divide by 2 to get rid of the 2 coefficient. So we have e to the x plus 3 equals 5. Take the natural log of both sides to get rid of the e. So you have x plus 3 equals the natural log of 5. And then finally subtract 3. And again, calculator answer, you would type in natural log of 5 and then minus 3. Just be careful with parentheses. I'll show you this just so you can kind of see it. Maybe if my calculator pops up. So if I want to do the natural log of 5, I'd hit the ln button. Just make sure you close out that parentheses and then do whatever operation after it. And you do get decimals for these. And then finally, the last thing you should know about E is you should know some basic operations and visual characteristics. So since E is just a number, we can treat it the same way we treat all exponent rules. So if we multiply E's together, we add their exponents. If we divide E's, we subtract the exponents. Every operation that you did with any other number would be true for E. The graph of E is an exponential growth graph. It's a very, very sharply rising graph. We think of it as the inverse of natural log. So if you think about what natural log looked like, it was a very slow growing graph. E is the opposite. It is a very fast growing graph. The domain of an exponential function is everything, goes forever left and right. It's all real numbers. Your range is everything above 0. There's actually a horizontal asymptote right along the x-axis that keeps my range everything that is positive. It is a strictly monotonic function, meaning it is always increasing. It is 1 to 1. It passes both the VLT and the HLT. And it also has a concave up look all the time. It always has a positive second derivative because it's always CCU. And then the end behavior on the left end heading towards negative infinity, it flattens to 0. It goes to that horizontal asymptote. And then on the right end, as we go towards infinity, it gets really big. It goes to infinity because it is an extreme growth graph, an exponential growth graph. Those are just the very basics from a non-calculus standpoint of what you should know about E. We use them a little bit when it comes to just some basic operations with it. For the most part, your attention will be spent on deriving and integrating, but this is a nice quick summary of the basics that you should know going into that.